Hello, C Block. Welcome to our third virtual lesson on scientific notation. So great job if you tried the warm-up finding the mass of an electron, which is number 1, the mass of Earth, the population of Earth, and the population of Milbury. So of those 4 numbers you wrote, 2 of them are actually already written in scientific notation. These first 2. This one's written in number word form, and that's considered standard form, the regular way we write numbers. So what does scientific notation mean, represent? How do we do it? All those questions will be answered. So scientific notation takes really, really large numbers, such as the mass of Earth, or really, really small numbers, such as the mass of an electron, and makes them easier to work with by making them values between 1 and 10, such as this first one, and that's also between 1 and 10. And then we write times 10 after it to some exponent. How do you get that exponent? Why are they sometimes negative? Why are they sometimes positive? Well, let's take a look at this third answer that's in number word form and actually write it into scientific notation. So 7.53 billion, I can make it into just standard form by writing out, I think that's billion, yes. All right, so really big number. Scientific notation would take that really big number and make it a value between 1 and 10, because those are really easy numbers to work with. So you move the decimal, which we don't really see right now, but it's always at the end of the number if you don't see it. Move the decimal to a spot where the value does become between 1 and 10. So I wouldn't want to move it here, that's 753. Wouldn't want to move it there, that's 75.3. But if I move it right here, 7.53, and drop any unnecessary zeros at the end, that's a number between 1 and 10. But these two are not equivalent. We need to keep them equivalent to each other so they represent the same number. So I'd write times 10 after it with some exponent. The exponent is represented by how many times we move the decimal. So I moved it 3, 6, 9 times. That's what my exponent's going to become. I use a positive exponent because it's a really big number. Anything actually greater than 1 would use a positive exponent. If it's a value that's small, such as the mass of an electron, anything less than 1 would have a negative exponent. So if we were to think of, say, maybe the mass of a paperclip, I'm just going to make up a number, but let's just say it's this really small value. That's a number less than 1. I can write it in scientific notation by moving my decimal so that it becomes a number between 1 and 10. 0.49 is not between 1 and 10, but if I move it one more spot, 4.9 is a number that is between 1 and 10, but these two are not equivalent yet. I would have to write times 10, oh, my marker's dying, after it, now with an exponent. I moved the decimal 3 times, so I would put a 3, but this is a number that's less than 1, so it would need a negative exponent. So I'd have times 10 to the negative third power. So that's kind of a quick overview of how to write numbers in scientific notation. I'll do one more, the population of Milbury. So this is a number greater than 1. It's going to have a positive exponent, and I want to make it a number between 1 and 10. So I'd put my decimal right there, but these are not equivalent yet. I'd have to write times 10 after it with an exponent. I move the decimal 1, 2, 3, 4 times, so it would get written like that, 10 to the 4th power. Now they're equivalent. The starting number is between 1 and 10, and every number in scientific notation needs a times 10 after it with some exponent. Again, it's a positive exponent, like in our warm-up. If it's a really large number, we use a negative exponent for any small number, anything that's less than 1. All right, so how does this tie into chapter 6 with what we were doing with exponents and the properties of exponents? Well, we're going to be calculating numbers, multiplying and dividing them in scientific notation and wanting our final answers to be in scientific notation. So let's just say I have the number 4 times 10 to the 8th power. That's written in scientific notation because my first number is between 1 and 10. Then I have times 10 after it with some exponent. And if I just put 2 times 10 to the 5th power. Say I want to multiply those two. How do we do that? We're going to multiply these first two numbers, the 4 and 2 together. 4 times 2 is 8. And then I'm going to write times 10 after. And we got to think about, we have times 10 to the 8th power and 10 to the 5th power. How do I combine that? Well, the properties of exponents that we learned last week say if they're the same base, you can add the exponents. So 8 plus 5 is 13. So these two numbers, if I multiply them out, would get me this answer. And that final answer is actually already written in scientific notation. First number is between 1 and 10, and then we have the times 10 after it, and our exponent. We have a positive exponent representing that this would be a really big number. If I wanted to put it in standard form, I'd have 8, and then I'd have to move the decimal 13 times. That would be that number. So it's a lot easier to have it written this way. So part of your classwork that I'm going to assign you today is actually multiplying numbers like this and getting your final answer in scientific notation. You don't have to convert it into standard form. So we just want to make sure all our answers are written with this starting number between 1 and 10, and then times 10 to some power. But what happens if we multiply or divide a problem and our final answer isn't in scientific notation? So let's take a look at, let's say I have 2.6 times 10 to the 4th times 3. Actually, I'll just do this. So I have 2.6 and 31. Yes, I know this is not in scientific notation, but we're just going to multiply this problem and have our final answer be written in scientific notation. So we're going to multiply 2.6 and 31. I got to multiply it out over here to see. So it'd be 80.6. So I have 80.6 times 10 to what power? Well, I have the same bases here. I'm going to add my exponents, 10 to the 9th. So I have this answer, but why isn't it considered scientific notation? It's because this first number is not a value between 1 and 10. I'd have to move my decimal over once. So I would move my decimal over once that way, and then I have to bring down the times 10. Now if I move the decimal over once to the left, I actually have to add 1 to my exponent there. So 9 plus 1 would become 10. So now these two answers are equivalent, but this one is in scientific notation. So that's with multiplying. What if we have a division problem? What if we were dividing 2 times 10 to the 3rd divided by 5 times 10 to the 6th? So we divide our first numbers here. 2 divided by 5, that would become 0.4. And then when we divide with the same base, remember the rule for the exponents? I subtract them. 3 minus 6 would be negative 3. But look at my answer here. It's not in scientific notation. This first number is not a number between 1 and 10. I actually have to move my decimal backwards 1. So if I move it over 1, now it becomes 4. 4 is a number between 1 and 10. But now I got to actually subtract 1 from my exponent. I move the decimal one place, I'm going to subtract 1. So it'd become 10 to the negative 4th. If I had to move the decimal 2 places, then I would subtract 2. Or if I had to move it 2 places up here, then I would add 2. So however many places you move the decimal, you're going to change the exponent that many times. Okay, so I have this all written out in notes that I'm going to share with you. Try going through the notes and try the problems I assigned and let me know if you have any questions.